Hello, sixth graders. I started the last video with these three items and we didn't get to number 3. To review, we defined subtraction to be the addition of an opposite. You do A minus B, you do A plus the opposite of B. Now, that opposite of B here is not necessarily a negative number. If the B itself is negative, then the opposite of a negative is a positive. I know it's a little tricky at first, but if you remember to say it that way, remember that I suggested that very often it's helpful to think of that minus or negative sign as meaning the opposite of. Here we'll think of it as A minus B, but here we'll think of it as the opposite of B. So A minus B is A plus the opposite of B. We also showed that although subtraction is not commutative, when you reverse the order of a subtraction, you don't get some random answer. What you always will get is the opposite of the other subtraction. Here's A minus B and B minus A. That's a subtraction with the order reversed. And if we add those two things, we showed last time that you get 0 because you have an A and a minus A and a negative B and a plus B. So the A plus the negative B add to 0, the B and the negative B add to 0, and you get 0. Now, if two things add to 0, they're opposites. And we went through examples last time showing that when we reverse the order of a subtraction, no matter what kind of numbers we have, that's what happens. We get the opposite of the other result. And number 3, we read this, of course, as the absolute value of A minus B. Keep in mind that absolute value can never be negative. The absolute value of a number is either 0 or it's positive, because absolute value means distance from 0. Now, if the A and B happen to be the same number here, which they could be, then A minus B would be 0 and the absolute value of 0 is 0. But if A and B are not equal to each other, then you're going to get a positive result because the absolute value of any non-zero number is positive. And distance is positive. Absolute value is distance from 0. So it shouldn't surprise you when I tell you that the absolute value of A minus B, where A and B are numbers, points on the number line, this will give you the distance between the 2 points. Very simple. The distance between the 2 points on the number line. Or in other words, the distance between A and B. We're going to explore that, and I'll tell you now that it'll be very similar to what we did last time, but in my opinion, subtraction is the hardest of the 4 operations with integers. There's some good news. When we get to multiplication and division, it's going to be easier. I'm going to be proving to you why and how multiplication and division work the way they do, but the rule for multiplying and dividing with integers is very simple. Addition and subtraction is more challenging. I think we've hopefully mastered addition, particularly that video with the vectors, where I compared the playing cards, the black and red playing card method that we looked at together, and then compared that to the vectors. Hopefully addition is pretty straight in your minds at this point. And now we have to get you to master subtraction, and it's really based on number 1. These other numbers 2 and 3 are to sort of help you to reinforce that. So let's look at the distance between 2 points on the number line. One quick thing before we get to distance on the number line. When I was covering the addition of integers, I neglected to show you an example of opposites adding to 0 as far as with the vectors. I'm going to now consider 3 plus negative 3. Opposites will always add to 0. When two numbers are opposites of each other, their sum is 0. And of course, down here, now that we know about the definition of subtraction, 3 plus negative 3 is equivalent to 3 minus 3, which is of course 0. But I just want to point out the vector addition. This right-pointing vector, which is 3 units long and has its beginning point at 0, is of course 3. And the leftward-pointing one, also 3 units long, is negative 3. And if we move one of them so that its beginning point is at the endpoint of the other. We could do it either way. I'll just do it this one way. What I've done is I've taken the -3 vector and I've put, it was over here from 0 to -3. I put its beginning point at the end point of the 3, and of course it's this is the answer. Wherever that the vector you move, wherever its endpoint is the answer, and of course it's at 0. And the reason, of course, that the sum ends up at 0 is because the two vectors are point in opposite directions and they are the same length. Opposite numbers have the same absolute value. They're the same distance from 0. So those two distances kind of cancel each other, if you want to think of it that way, and you end up at 0. When we were doing the playing cards, this would be a black 3, this would be a red 3, and we said that each black spot cancels a red spot, and so you have no spots left over. You're at 0. So that's a little bit of a review of vector addition, and also confirming that opposites will add to 0. Let's start with this situation that any first grader can appreciate. What is the distance on the number line between 1 and 5? And with distance, of course, we're counting spaces, not so much the points. If you start here at 1, you're not going to count 1 until you get to the 2. When you go from 1 to 2, that's 1 space. And then 3, 2 more, and 3 more, and 4 more. Of course, the distance between 1 and 5 is 4 units. And if you do 5 minus 1, and I'm sure that first graders will be taught this, if you do 5 minus 1, you get the distance between 5 and 1. So this distance between two numbers on the number line is not a sophisticated concept, but we're going to show that it works for any kinds of numbers. What if we did the subtraction in the reverse order? What if we did 1 minus 5? Well, that, of course, is -4. Now we're getting into the area where first graders would not consider this, of course. But what do you notice here? As we saw in the last video, when you change the order of a subtraction, you get opposite results. So here we get -4. Well, we cannot say that the distance between 1 and 5 is -4 units. That doesn't make any sense. There's no such thing as negative distance. So what we could do is we could say that this is the distance between the 1 and the 5. The absolute value of 1 minus 5. The absolute value of 1 minus 5 is the absolute value of -4. And the absolute value of -4 is 4, because -4 is 4 units away from 0. So notice when we had the bigger number first, we got the distance. When we have the smaller number first, we get the opposite of the distance, which allows us to then take the absolute value of that result, which came out to be negative. But if we take the absolute value, we get the distance. This is what that absolute value of A minus B was all about. When we say that the distance between two numbers is the absolute value of A minus B, we don't have to worry about which of the two numbers is bigger or which is smaller. This first example illustrates that, and all the others will. You see, once again, there could have been a two-part rule. Let me show you that. There could have been a two-part rule for the distance between two numbers on the number line. So let's take A and B. Right now, our first inclination might be to put the A on the left and the B on the right, but it doesn't have to be that way. So we don't know where A and B are. We don't know which is bigger, which is smaller. What we could say is that the distance between A and B, whoops, I didn't want the absolute value there. We could make a two-part rule and say the distance between A and B is A minus B if A is greater than B. Right? If the first, when you do a subtraction, if the first number is bigger, you get a positive number. But then we have to consider the other case. We'd have to say that the absolute value, the distance between A and B would be B minus A if B is greater than A. So this is a two-part rule for determining the distance between A and B? Any 2 points A and B on the number line? Well, isn't a one-part rule simpler than a two-part rule? If you understand the concept of absolute value, it is. You see, we can just say, here's the other alternative. We can say that the distance between A and B is the absolute value of A minus B. And then we don't have to worry about which is bigger and which is smaller. That's the beauty. That's the beauty of this concept of absolute value. And it's not just here. There will be many examples in the future in high school math where you're going to deal with this concept of absolute value. So let's get back now to two other examples I think we need to do. Two other examples. We've just did where the two numbers are both positive. How about if the two numbers are both negative? Well, let's keep it simple and have the answer be 4 each time. We'll make the answer be 4 units each time. Now, clearly, the distance between -5 and -1 is also 4 units. You can count them. 1, 2, 3, 4. All right. Well, let's do this. The distance between -1 and -5 on the number line. Let us do it like this. -1 minus -5. This is going to give us the answer. To distance. Distance has to be positive or 0, but distance here is clearly not 0. Bigger number minus smaller number. -1 is bigger than -5. And according to our definition of subtraction, to subtract -5, we add +5. To subtract a number, add its opposite. So this becomes -1 plus 5, which is +4. If we had done it the other way, -5 minus -1, this time it's the smaller number minus the bigger number, so we're going to get a negative result. To subtract -1, you add the opposite of -1, you add +1. So this becomes -5 plus 1, and that's -4. So once again, we got the two results were opposites of each other. This one gives the distance. The one that gives the positive result is the distance. And if you do the bigger number minus the smaller number, you will get that distance. You will get that positive result. But if we just don't want to say which one's bigger, which one's smaller between the A and the B, we just say the absolute value of A minus B. Because if we had taken the absolute value of this one, we would have gotten +4. The absolute value of -4 is 4. Okay? One more example. I said that just for kicks, we'd make all of the answers come out to be 4. Well, notice something here. This is kind of instructive. If I take -1 as one of the numbers, I can't use 5 this time. Right? Before I used 1 and 5. That distance was 4. And I used -1 and -5. That distance was 4. But what is the distance between -1 and +5? You see, you might have thought that would give the same result, but it doesn't. Think about it. The distance between -1 and 5 is 6 units, not 4. So to get that 4, I chose -1. Then I would have to choose 3. So if we do 3 minus -1, again, it's the bigger number minus the smaller number. To subtract -1, add +1. So this becomes 3 plus 1, or 4. If we did the subtraction in the other order, small minus big, it would be -1 minus 3. -1 minus 3. Now, at this point, you should be able to realize, without me having to rewrite this, I am going to rewrite it, but you should know that this is -4. -1 minus 3. This is kind of the new thing about subtraction, one of the things that might be challenging. This result is -4. It is equivalent to -1 plus -3. You can always bring a subtraction back to an addition. You can rewrite a subtraction as an addition. To subtract 3, add the opposite of 3. The opposite of 3 is negative 3. So subtracting 3 is the same as adding negative 3. And if we think of the vector addition, or even two red cards, a red 1, red 3, add them together, you get 4 red spots. The vector addition would result in negative 4. So once again, when we did big minus small, we got the distance, which is positive. When we did small minus big, we got the opposite of the distance. If we were to take the absolute value of this, we'd have the distance. And that's what this formula is all about. So let me write it here one more time. It's kind of cool, I think. I hope you agree with me. When we take any two numbers, A minus B, we take any two numbers on the number line, A and B. They can be literally anything. If you do A minus B and then take the absolute value, just in case A minus B gives you a negative number, in case that happens, you take the absolute value and you get the distance. I think that's it. We'll call it quits for now. Take care, 6th graders. Integer operations, that's where we're headed. Soon we'll deal with multiplication and division. There'll be a proof or two in there that it's important to explain why things are the way they are, but the rule for, or the rules for multiplying and dividing with integers are quite simple. You'll see. Take care. Bye-bye.